Hello, everybody, and welcome back to another episode of Oxygen Not Included. So, last episode we put in just a little bit of pin pocket to start producing diamond, and we're gonna start this episode utilizing these thermal gas fissures with these marine drills to start getting basically infinite natural gas. Um, but before we do any of that, I'm gonna expand down this diamond window tile here further out into the magma, just because it's gotten so cold that this door is always closed and you can see the temperature is constantly decreasing. We just need more hot rock that we're directly touching. So, I mean, you can see it's cooled down all the way out like here almost. Oh, is there almost there's nothing left in here that's 1200 even? Okay, a little bit right through here. But there used to be a lot more heat in this entire region. We're definitely sucking it out fast. So, I mean, you can see on the relative temperature, you can see the cold that right here. It's like everything outside of this is still pretty hot, but directly touching it is cold. So, I'm gonna break back in here. I'm gonna make a little vacuum room somewhere over here, and we're going to just break in and try to delete as few natural tiles as we can and go across here. All right, so I broke a little ways in here. I vacuumed out this space so that they don't, burn themselves. I have to avoid this accidental pocket of steam I created. It's about 1,000 degrees. Otherwise, that would scorch them. And this, I'm just making like a little maintenance thing so we can get in here. And I don't want to dig, as I said, I don't want to dig more obsidian or igneous rock than I need to, because it'll cut the mass in half and delete half our heat, essentially. So, all right, now that this is in, I guess I need to figure out how I want to expand this. Let me come up with a little plan. So I ran out of diamond pretty quickly. Even though we're growing it, it still takes cycles upon cycles upon cycles to make it. Um, so I switched over to using iron because iron and steel are the only two metals I currently have that will not melt in this area. And iron has one better watt per degree K difference than steel. So I chose iron. And it's also cheap because we don't have to then make a bunch of steel. Um, and okay, good. Once those tiles finished there, hopefully the temperature up here will go up a little bit more. It is. We're able to draw a little bit more heat out from down like this far even. You can see the temperature is changing all the way out this way now. That's the goal. Once we finish more of these tiles and these temp shift plates and get out into the 1000s out this way, hopefully it'll increase the rate that we can bring up the temperature in here. We'll see. It's pretty difficult to move this much temperature this far quick enough for whatever, how much cooling we're doing, essentially. We have this pocket down here. Actually looks like it's about to run out, and then we have this pocket over here. It's also about to run out. But both of these vents are active currently, although this one's about to be dormant. So once the rate of cooling in here slows down, if one of these shuts off, then we will be fine on heat, probably. We'll see. It is still increasing, you can see slightly here. Every time that door opens, it slows down because it stops transferring heat, these temp shift plates. Since they don't transfer heat with each other, which is really weird. And I would have to put in... actually, I could probably replace, like, down this. I could probably do metal tiles, like, here, every other one, because they can just climb up the ladder like that. And it would be much more efficient. But we will see if I need to do that or not. So the input water has mostly, we've gone through the buffers. This basically means the vent is probably, it must have just erupted. But you can see that the water's still being handled, sent out here, and then sent up to space. And we've gotten the temperature of this tile back up to over 200 degrees. It was down to like 140 before I started putting in all of this. So this is definitely helping. We'll see if this door ever opens again. It might actually get hot enough on this tile again to close it. The steam turbines are almost back up to running at 100% as well, which would be nice. Let's see. If I keep putting in... Basically, all I do is I just go in here and I go, we'll build a few more iron shift plates and slowly keep drawing the heat out. Also, I realized I don't really need to build the outer like shell. I can just do it with the actual obsidian and igneous rock. The temp shift plates should make up for the difference in thermal conductivity. At least that's the hope. Maybe it is significantly cooler on this side than it is on this, so maybe I do need that. But we'll see. If I need more heat, then I'll get more that way. I think what I'm going to do now, though, is shift away from working on this episode, and I'm going to start working on gas fissures. I said I was going to last episode. This looks like it's fine. It's working. Even if it gets colder again, it still works. So, on to the thermal gas fissures. We need to figure out a way to capture them. Oh, poor glow squid. Well, I guess I could actually just... the other one. Maybe someone will come along and save them. We'll see. Oh boy. This takes... Looks like a decent bit of time, and it takes... Oh my god, look, the kilograms of diamond drain away as it runs. Oh boy. Okay. Fine. This is gonna be a little bad because it's gonna be a mix of... I tried to drain this polluted water out of here, and it did not end up happening before this would go off. Okay, let's see. Can it show me how long or anything it's going to last for? It's emitting 83 grams per second of 83.3 grams per second of natural gas. Really wish that polluted water wasn't... Yeah, like that. Just drain it out. I just wish it would tell you how many seconds it would take before it's built up. It kind of looks like a cycle. It's at 15% and running for not too long. I'm not sure. But it kind of seems like it'd be a cycle. No matter what, though, it is 83 grams per second of natural gas, which is very nice. Just need this polluted water to get out of here. Fun. Alright, let me get that out of there. Alright, so this was my first design for, I guess, taming one of these thermal gas fissures. It is working. And we do have quite a bit of natural gas in here. But as you can see, there needs to be a liquid lock here. And it's quite power hungry. This could consume 1.44 kilowatts on its own. And is always, because the gas pump is always running while this is active, which this should always be active except for when the grill is. So I'm trying to decide how I could make this a bit more efficient for the next couple ones. I'm going to leave this one for now. It works, it's good enough. But I think for the next one, I'm going to try to have a bit more automation to auto-supply the diamond, auto-remove the sulfur buildup, and make sure this gas pump isn't just running constantly. Because it's just... This does not produce anywhere near the amount that would require having a gas pump run. Honestly, I could probably do this right here, even now. I was thinking of just having a ammo sensor in here and saying, like, when the gas pressure gets above, like, I don't know, probably like 1 kg or something, then we'll turn the gas pump on until it gets down below a certain amount. Something along those lines. Just so we don't have to have this constantly running so much. Yeah, I think I'm going to figure out a way to do And I don't want it to just be like when it's above 1 kg, because that's kind of useless. I want it to be like when it gets above 1 kg, turn on until it gets below a certain amount. So I'm going to do some circuits to figure that. Okay, I couldn't help myself and I made a few minor changes. Basically what I've done is I've closed this off so duplicates will never go in here, hopefully. The first thing is we have an Atmos sensor that basically reads, which is about to turn on. Once it gets over 2 kgs of gas pressure in here, it turns on this gas pump for 64 seconds. And that should be enough to suck out all of the gas from inside of each of the tiles in here. Or at least plenty low enough that it won't be on all the time, essentially. Which you can see once this gets done, it's already down. It's down to about 100 grams and it's over. This doesn't produce very much very fast, so it doesn't turn on too frequent. And then what I've done is I've set up a little conveyor loader out here, which is going to take, it takes diamond from the dupes that they deliver it, and then it drops it into this room. And I just have a little weight plate in here to make sure we have a constant little stockpile of it. And so I'm going to wait a little bit longer and see if hopefully the auto sweeper in here can automatically supply this diamond to the marine drill to essentially, I guess, I don't know what the word would be, but to fix it or whatever. And so that means that no dupe would ever have to come into this room and it'll just constantly be producing. And it draws 0 watts when like just idly. So that's what I was hoping for and wanting, is not to have it constantly using power, because I plan on just running every single one of these off of like 1 or 2 conductive wires, and hopefully they won't go off at the same time, otherwise then it will break, but it probably won't. And if it does, it's not going to be the end of the world. It'll just mean like the gas might be a little higher pressure than normal and it'll just run for a little bit longer. So yeah, you can see, so this holds a ton of diamond, which is a little inefficient. I wish I could set this to hold less, but I don't believe you can. So we're just going to deal with having that much diamond stockpiled and buffered, and we're going to have natural gas come in up here. It is 100 degrees. At least that's what it's outputting here at. It's 100 degrees. So I don't know, but once we burn it, it goes down in temperature by a little bit because it comes out as polluted water and carbon dioxide. So now I'm going to try to build a few more of these systems around after I check to make sure that the auto super can diamond. And I'll try to refine the design for each of the next ones as I go on this one. Yeah. See the gas pump turned on. It got down to about 100 grams, and it's back to waiting for pressure to build up. All right, let's see. So the marine drills is turned on, and it did auto supply the diamond, picked up all the sulfur, and everything still works. So on to the next fissures. Probably stop in if I make anything very notable with each different design. All right, the second one is done. I built the liquid lock into the base here, so we don't have to deal with having these manual airlocks. And you can see it's working. The drill is actively working. And you'll see when we finish here, this diamond is going to be auto-replenished. There is a little bit of diamond sitting on this weight plate here. And then there's a little bit of diamond right at the bottom just from mining the biome. And so, there we go. It picks up the sulfur, deposits it here, and that'll drop there. And then it looks like it must have enough diamond for the next operation, so it doesn't refill it. I think it uses 100 kgs of diamond per operation, which is quite a bit. But we produce 100 kgs of diamond roughly a little over every cycle. Like 1.2 cycles or something is how often we produce diamond. And we also mined a lot of it in that biome. So, autosaves. We're not doing bad for diamond, and this will produce us quite a bit. And you can see the natural gas, just the gas pump just turned on. we're just filling this. We don't need to actually fill this at all. Oh, who's fleeing? Well, someone's fleeing. Surely, yeah, okay, let's see. Let me guess, there's a... Why were you all the way up here? What were you looking for? Oh, it must be somewhere else. Is it? Oh, it's in the bedroom, of course. Okay. Kill it. Okay, we're good. I keep forgetting. Is there? Yeah, there is an egg in here. Let's relocate that to like, I don't know, here. I keep forgetting about it, and it keeps becoming a problem. Oops. I do need to get more dupes. Things are slowing down a little bit just because we have so many tasks. But I kind of want to work on food a little bit better. Actually calculate out food. Um, so that's another one of these thermal gas fissures tamed. And I have 1, 2, 3, 4 of them left, looks like. So, yeah, bit more work. I think what I'm going to do is I'm going to end the episode here for the day. We did quite a bit. We expanded out this down here, which this is working great, by the way. The time tile on this side is back up to like 600 degrees most of the time. And it's pretty easy to expand this. We could just mine a few more tiles, add some more temp shift plates, and it'll keep transferring the heat through. And then we also built out these 2 tamers for the thermal gas fissures. And I think what I'm going to do is off camera between episodes, I'm going to build out the remaining 4 thermal gas fissures here, because that's going to take quite a bit of time and be pretty boring. And then next episode, I think we'll get into probably making a central spot where we bring all this natural gas to, and we can have like a little power plant with natural gas generators just in case we need it. Although you can see this backup one hasn't turned on once in the past 5 cycles. So do I need it? Not really. This is a pretty good power plant, these 4 steam turbines. Even if they constantly have to be running an aqua tuner, it's not like we're pretty fine on power. We don't use a lot at once, usually. So, but I think still collecting all this, it'll produce a lot of polluted water for us as well, which we can then immediately dump back into here, clean it, and then use it for whatever we want. I do think I might put in an aqua tuner once we build that power plant to cool down this entire water tank from 95 degrees. It would be quite nice just to have some cool water that we can use anywhere in the base. Not that we are running low on water. This tank has gotten a little bit low, but it's still mostly full. So we're doing quite well. So yeah, that's where I'm going to leave the episode today. And thanks everybody for watching, and I'll see you all next time.